the line voltage. Okay, clear? See, this is your paper question from June 2019. They said three similar impedance each of 20 minus J16. So we can consider Z is given. Z is how much? 20 minus J16 is given. And they said it's a star connection across a 300 volt. Voltage is always the line voltage until and unless they didn't mention. Like they didn't mention over here. So we automatically consider it's a line voltage. Three phase, three wire. So as you know, in the star connection, and this is the case of similar impedance, means it is a case of balanced case, right? It is the case of balanced. So in the star connection, VL is equal to root 3 of VPH, and you know the formula VPH is equal to IPH multiplied by ZPH. VPH is how much? VL by root 3 from this relation which we have studied. IPH we need to calculate. ZPH is given 20 minus J60. So VL is given 300. So it would be 300 by root 3. Now can you get the value for IPH? Tell me first. So after calculation of IPH, you will get this value. And as you know, in the star connection, current is equal. So line current is also the same. That is IPH, that is 6.7 and angle 38.6. Now you need to calculate the power factor. Power factor is what? Cos phi, right? So tell me, how can you get the phi, phase angle? Cos phi, see, calculation of cos phi, you will have two methods. One of the method, cos phi is R by Z, and they have given Z as 20 minus J16, right? 20 minus J16. So if I'll compare it, then it would be R minus JXC, right? If I'll compare the standard equation, so R will get it as 20, correct? And Z, how we'll get the Z? Convert this Z from rectangular form to the polar form. Can you tell me what will be the form of polar form? 20 minus J16? Whatever the magnitude you will get it, that will be the Z. Okay? So after solving, you will get it as 0.78. This is one of the method. Another method is whatever the angle you will get it for the Z, that is phi. Okay, like 20 minus J16, you need to convert it into the polar form. Then it would be 25.61 and angle is 38.65, right? Minus you will get it, but the angle, how much you are getting phi, that is 38.65. So you can do it directly also. Cos of 38.65 is 0.78. So this is one of the method. This is second method. Second method is more easy, that whatever the angle of impedance is equal, that is equal to the phase angle only. Okay, now you need to calculate the active power, reactive power and apparent power. Calculate it. As you know, the formula for all active power formula is root 3 VL IL cos phi. See, the power formula is root 3 VL means the line voltage. They have already mentioned. I told you VL is how much? 300 volt. So multiplied by 300 multiplied by the current. Current, how much we are getting? Current is same, 6.7 multiplied by cos phi. Cos phi you have already calculated, that is 0.78. Okay, one thing. Next thing, write down this point, that never use angle in while calculating power. Okay, as you can see that I didn't use angle, I just used the magnitude of the VL, I just used the magnitude of the IL, right? I didn't use angle over here. So never use angle while calculating any power, whether it's an active power or reactive power or an apparent power. Got it? So I'm telling you the value that active power after solving you will get it as 2744.5 watt. Reactive power you will get it as 2178.77 VAR. Do this question in your homework, and if there is any problem then let me